students. In this video we are going to discuss about registers. So we know very well what is register, right? So in order to store the data we need registers. Not only to store the data, in order to store memory address also we need register. Register is a collection of flip-flops. Register is a collection of flip-flops. You know very well what is that flip-flop. Each flip-flop store one bit, either 1 or 0, right? So based on our requirement, if it is 8-bit register means we need 8 flip-flops. If it is 16-bit register means we need 16 flip-flops. Okay, so based on our requirement and applications we can use the registers. We can vary the bit length of the size of the registers. Based on the size of the register we have to use the flip-flops, right? So as we know that in our CPU, central processing unit, we are using many registers such as accumulators, right? Memory address registers, memory data registers, general purpose registers, program counter, and instruction register. You know very well what is this accumulator. Accumulator means what? So it stores the result, right? For example, if you are doing some addition operation means the output of the addition, right? It stores, the sum stores in the accumulator. Okay, sum a comma b, right? So it stores add a comma b. It stores the result. It performs the addition operation and it stores with the accumulator. So memory address register. This registers holds the memory address. Memory data registers, it stores the address of the data. And general purpose registers, we have many general purpose registers. So based on the what type of processor we are using, right? So from microprocessor to 8085 current generation is Intel Pentium 11th 12th generation of processor also we are using, right? So up to 64-bit and also 128-bit processor also we are using. So in order to speed up our computation, data upload and download and performing multiple tasks, we need bit size high, right? So if bit size of the register is low, right, so it performs very, the speed of the operation very slow, right? We need very fast operations. So memory operations are we now in order to perform multiple tasks we need um, larger size of registers, right? So here general purpose registers are B, C, D, E, H, L. So it stores the temporary data in the general purpose registers. Then program counter, you know very well what is that program counter. Program counter points to the next execution of instruction. Instruction register points to the address of current execution of instruction. You know very well all these registers, right? We will see how we are going to design the shift registers. So as I said, so shift registers means it stores the data and performs shift in and shift out, right? These two functions perform in the shift registers, right? So for example, so it is a 1 2 3 4 5 6, this is a 8-bit shift registers, right? So initially all the flip-flops, which means if it is 8-bit shift register means we are using 8 flip-flops to store the initial data. Initially all the flip-flops stores zeros value, right? Now I will, for the first clock pulse, I am giving the input 1, right, at the MSB side. This is your MSB, this is your LSB, right? So for the first clock pulse, the first flip-flop stores, MSB flip-flop stores 1, the remaining bits are 0, 0, right? So I am feeding the input, data input 1, it stores in the MSB, whatever the previous result, the previous output of the first MSB flip-flop is 0. That one is shifted to the next flip-flop. Again, this second flip-flop is shifted to third. Similarly, it will shift up to this one. Then what is this, ma'am? So this is your shifted output, right? Is a last bit. So whatever it is storing in the LSB bit, so we are receiving as a output, right? Shifted out. Similarly, again I am feeding the next input as a 0, right? So now this MSB bit value is shifted to the second flip-flop. Similarly, I am feeding the third input as a 0. Again, so this 0 is entered to second, this 1 is entered to the third flip-flop. Next, I am going to feed data as a 1. So in the MSB as a 1, this output is goes to, it is a shifted right operation, right? Again like this and like this. So it is a shifted, it is a right shift, right? Whatever it is there in the LSB, we are taking that one as a out, right? At the finally all the flip-flops stores 1 0 0 1 4 zeros. This is your final results of flip-flop. Whatever the flip-flop stores, it stores within this. Until then, if you are giving the next input or next clock pulse, right? In the LSB, so the shifted out values are 4 zeros. Okay, so we have different types of shift registers. We will discuss in the next video. Thank you.